Good morning everyone. I am Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to discuss about digital altimeters. What are the types of digital altimeters we have? In the last lecture we have discussed about one of the digital altimeter and next one is integrating type of digital altimeter. Why we choose this integrating type of digital altimeter means with this integrating type of integrating type of digital altimeter. This is one type of digital altimeter used to get the output frequency. That is, in integrating type of digital altimeter we can convert voltage to frequency. So this is the block diagram, and the main blocks present in this integrating type of digital altimeter are pulse generator, comparator and digital frequency meter. Along with this we have an integrator at the input section. So this is called as integrating type of digital altimeter. In this integrating type of digital altimeter, coming to the operation, we are applying the input signal to an integrator. In this we are applying a constant input. Whenever we apply the constant input to an integrator, it produces the output as, if you apply a constant input to an integrator, the integrator produces an output voltage and that is given to the comparator. So one end of the comparator is the output coming from the integrator, whereas another end of the comparator is the reference signal ER. Whenever the reference signal and input signal, if both are same, then the comparator give the signal as generate the pulse. So according to that, the pulse generator generate the pulses, and those pulses, with the help of pulses, we can find out the frequency. The duration where the pulse generator generate the pulse, that is indicated on the digital frequency meter. If you see the output waveform of an integrating type of digital altimeter, this is the pulse generator. So in this pulse generator, the time where we are generating the pulses, so whenever a pulse is generated, then the pulse is given to an integrator. So whenever we apply a pulse, that is a negative going pulse, whenever we apply a pulse, then capacitor charges, and if the capacitor charges completely and whenever it reaches to a maximum or peak point, the capacitor starts discharging. While the capacitor discharges, if the output voltage across the capacitor is equal to the reference voltage, then comparator gives the signal that send the next pulse to the pulse generator. Like this, the pulse generator generates the number of pulses and the time period will be indicated. Frequency will be indicated on the digital frequency meter. See here, initially with the help of input, the capacitor charges to a maximum value or peak value. Whenever we apply a negative pulse, the capacitor starts discharging and it reaches to a minimum value. Whenever it reaches to the minimum value, again with the help of input signal, the capacitor charges and it reaches to a peak value. The capacitor reaches to the peak value, its output voltage is equal to the reference voltage, then comparator will start producing a pulse. Then comparator produces the pulse. So when the pulse is generated, due to the negative going pulse, the capacitor starts discharging. Like this, the charging and discharging action takes place in integrating type of digital altimeter. Once again, verify the operation of integrating type of digital altimeter. In this, we have pulse generator to generate the pulses and comparator is used to compare given to input signal. With the help of digital frequency meter, we can measure the frequency of incoming signal. Now, Coming to the operation, initially we are applying a constant input to an integrator. Then the integrator produces an output. That output is given to the comparator. Whenever we apply a constant input to an integrator, it produces a slope in the output that is given to the comparator. This comparator will compare the output coming from the integrator with the reference voltage. Whenever the output across whenever both the inputs are same for the comparator, then comparator sends the signal to the pulse generator to generate the pulse. That may be a positive going pulse or negative going pulse. In this pulse generator, it generates a negative going pulse. So that negative going pulse is applied to an integrator so that the capacitor starts discharging. Whenever capacitor discharges, it reaches to a minimum point. Then, due to the input voltage, again the capacitor starts charging and it reaches to the maximum value. Whenever capacitor reaches to the maximum value, which is equal to ER, then comparator sends the signal to generate another pulse. Again pulse generator generates the second pulse. So, with this pulse, the capacitor starts discharging. Like this, the capacitor will start charging and discharging with the help of input and pulse generator produces an output voltage like this. Here T1 represents the charging time and T2 represents the discharging time. The T1 and T2, with the help of T1 and T2, we can measure the frequency. This is called as integrating type of digital voltmeter. In this integrating type of digital voltmeter, we consider only negative going ramp or positive going ramp. Either negative or positive going ramp is allowed because the input voltage is maintained as constant, that is positive. So we have positive slope only at the output of integrator. That's why instead of using this integrating type of digital voltmeter, we go for dual slope integrating type of digital voltmeter or dual slope type of digital voltmeter. This is the construction of dual slope digital voltmeter. In this dual slope type of digital voltmeter, we have comparator, integrator and counter. Next, this is a gate and a switch drive and flip-flop. These are the main blocks present in the dual slope integrating type of digital voltmeter. The main difference between dual slope and normal integrating type of digital voltmeter is, in normal type of digital voltmeter, we are applying constant positive input voltage only. But in dual slope, we have both positive input voltage and negative input voltage that is applied to an integrator. Now coming to the operation, before starting the operation of this dual slope integrating type of DVM, we have to make this counter 0. Initially the counter is 0. Then initially the counter is 0. We make the counter is 0. As the count has any value, the output may be changes. So that before starting the operation of any circuit, we make that counter is 0. We have to reset the counter value. Whenever the counter value is 0, with the help of switch drive, we choose the input voltage as the positive. With the help of switch drive, the positive input voltage is connected through the switch and that is given to an integrator. Whenever we apply a constant positive input voltage to an integrator, it produces the output as positive going ramp. As the input voltage increases, the capacitor starts charging and it reaches to a maximum value. If the input voltage is greater than 0, whenever the input voltage is greater than 0, or if the input voltage just reaches the 0 value, the 0 comparator detector give the signal to the gate, open the gate. When the gate is open, with the help of oscillator, we generate the pulses and those pulses are passing through the counter. Now, the number of pulses passing through the counter will be counted by this counter. As the number of pulses increases, the count value increases, and then finally it reaches that the count value is equal to 1, 0, 0, 0, 0. The total count present in the counter is 1, 0, 0, 0, 0. Now, the flip-flop state is changed from 0 to 1. Whenever the flip-flop state changes from 0 to 1, it switches the drive from plus ER to minus ER. Now, the input value changes from plus ER to minus ER. As the input changes to minus ER, we are getting the negative slope. Whenever we observe a negative slope, if the input voltage negative slope, then capacitor starts discharging, and here if whenever the input voltage is equal to the ground, then it stops the gate, then oscillator stops sending the clock pulses. During the time interval T1 and T2, the gate is open. During the time T1, the gate is open, and after completion of time T2, the gate is closed. Total time duration T1 plus T2. During this time interval, how many number of clock pulses are passing through the counter will be counted, and that will be displayed. This is called as dual slope integrating type of digital voltmeter. If you observe the output waveform, this is dual slope integrating type of DVM. If you apply a positive input voltage, we have positive going ramp. Similarly, if the input voltage is minus VR, then we have negative going ramp signal. Once again, verify the operation of dual slope type of digital voltmeter or dual slope integrating type of digital voltmeter. In this, we have different blocks like integrator, comparator and gate, counter or display unit, flip-flop and switch drive. Initially, we have to apply the input voltage. Before applying the input voltage, we make the counter value as reset. So, reset the counter. Now the count is 0. Then apply the input voltage with the help of EI. Because whenever the count is 0, the flip-flop has the value 0, which is given through the switch drive. So, initially, the positive input voltage is applied to an integrator. Then, if you apply the positive input voltage to an integrator, the integrator produces an output where positive going slope or positive going ramp signal is obtained. This positive going ramp signal is obtained. At the same time, the capacitor charges to a maximum value. As the capacitor voltage increases, it is greater than 0. Then the comparator sends the signal that open the gate. As the gate opens, the oscillator will send the clock pulses through the gate. So, as long as the gate is open, the oscillator will send the clock pulses, and the number of clock pulses passing through the counter will be counted here. Now, the number of clock pulses passing through the counter increases, and finally it reaches to 1, 0, 0, 0, 0. As the flip-flop has the value 1, it switches the drive from plus EI to minus ER. As the value is equal to minus ER, instead of getting positive going ramp, we obtain a negative going ramp, and capacitor starts discharging. As the capacitor discharges, the output across the capacitor is equal to the ground value, and then gate will be closed. Till the gate is closed, how many number of clock pulses passing through the counter will be displayed on the display unit, and whenever the flip-flop changes from 1 to 0, again it switches the drive, then instead of minus ER, the switch is connected to plus EI. So that we are applying both constant input voltage, that is both positive input voltage and negative input voltage to an integrator circuit, so that we have both positive going ramp signal and negative going ramp signal. This is called as dual slope type of digital voltmeter. As we have dual slope type of digital voltmeter, we have both charging and discharging time intervals that depends upon the input voltage. Next one is staircase ramp type of DVM. This staircase ramp type of DVM, this is one type of digital voltmeter. Here the input voltage varies in step. And finally, whenever the input voltage is equal to the reference voltage, then we get the output. But here the step size is maintained as constant. Whenever there is a change in the input, the change in the input varies in step, but the step size is maintained as constant. Coming to the circuit operation, we have a clock signal and counter, display unit, reference voltage, DAC and voltage comparator. Similar to the previous one, in the staircase ramp type of digital voltmeter also, before starting the operation, we have to make the counter value as 0. Initially, the counter is resetted, so the count value is 0. Then, we have to start the operation. Whenever we start the operation, we are applying the input voltage to the comparator, that is VI, and that VI is given to the input voltage is given to this comparator. At the same time, the another input we are applying to the comparator is the reference voltage, and that reference voltage is converted into a digital, and that is given through the comparator. That is given as the another input to this comparator. Whenever both the inputs are same, then the gate will be opened and the clock pulses will passing through the gate. Then how many number of clock pulses will passing through the gate will be counted by this counter, and finally that is displayed on the display unit. But here, whenever we apply the reference voltage, if that input reference voltage is converted into analog data and that is given through the comparator with the help of n voltage VC. Here, if the input voltage is not equal to the voltage applied through the DAC input, then we have to increase the step size of this reference voltage. How to change the step size of the reference voltage means that depends upon this count value. That is, see here, initially if the reference voltage is 0 volts, but this is the reference voltage 0 volts and we are applying it to a comparator. Now the input voltage is assumed as 5 volts. Here the input voltage is not equal to the reference voltage. Then that information is given through the gate. Then the clock pulse will be sent by this gate and that is counted by the counter. Now the count value is equal to 1. We are sending this count information to this DAC. This DAC will convert this digital data into analog data and that is given to this comparator. Again, the comparator will compare the input signal with the input coming from the DAC. If both inputs are not same, then again it will send the information to the gate. Now clock pulse will be passing through the gate and that is counted by the counter. Now the count value is changed to 2. Again, the counter information is converted into analog data with the help of DAC and that is again given to this comparator circuit. Again comparator will compare both the inputs. If both the inputs are not same, again clock pulse will send, then counter will count the clock pulses. According to the count value, the the count value is converted into analog data and that is compared in the comparator. Each and every time the number of clock pulses are counted with respect to the count value. The count information, that is the digital data, is converted into analog data. That analog information is given to the comparator. Again comparator compare the two signals till the process is completed, till both the inputs of comparator are same. Whenever both the inputs of comparator are same, then it gives the signal that stop the count, and during the time interval how many number of clock pulses are passing through the counter will be displayed on the display unit. This is called as staircase ramp type of DVM. If you observe this output of staircase ramp type of DVM, this is the input voltage and this is our applied input. Whenever both the inputs are same, so this is the input voltage and this is applied voltage. While we are applying the input voltage and the reference voltage to the comparator circuit, always the comparator will compare the input signal and according to that clock pulses will passing through the counter. Then that digital data is converted into analog and that is given to the comparator. The count value is increased by a step every time, so that the output voltage coming to the DAC also increased by one step for each clock pulses. So as long as we increase the output coming from the DAC by one step till the input voltage is equal to the voltage coming from the DAC. So the time required to obtain the output voltage across the comparator is equal to the input voltage will be measured and that is displayed on the display unit. During the time interval, initially VC and VI both are different, so that comparator is start to sending the clock pulses with the help of clock generator. As long as clock generate the clock pulses, the counter will count the number of clock pulses and according to the count value, that digital data is converted into analog data. That analog information is compared till the input voltage is equal to the comparator voltage. So how much time required for the comparator to equate the input voltage with the VC voltage, that is displayed on the output. The time required for the comparator to equate the input voltage with the output coming from the DAC is displayed on the display unit. During this time interval, the gate is opened. This is staircase ramp type of DVM. Why we call it as staircase ramp type of DVM means, in this the voltage coming from the DAC will varies in step by step for every time. So that's why it is called as staircase ramp type of DVM. And next one is successive approximation type of digital voltmeter. This successive approximation type of digital voltmeter, this always depends upon this successive approximation type of DVM. The basic principle involved in the successive approximation type is the counter, that is balanced type or balancing mission. Based upon that balanced mission, how can we balance an unknown weight with the known weight? The same process is involved in the successive approximation type of DVM. How to measure or how to find out unknown weight with the help of known weight by using balanced method. The same process is involved in successive approximation type of DVM. For example, if we have an unknown weight, this is unknown weight and this is known weight. The known weight is assumed it as 5 Ks. Whenever we compare the unknown weight with the known weight, if this unknown weight is greater than the known weight, we have to increase the known weight to some 6 Ks. Again, if you compare unknown weight with the known weight, again the unknown weight is greater than that of the known weight, then we have to change the known weight to 7 kgs. Again, the unknown weight is greater than that of known weight. We have to increase the known weight to 10 kgs. Again, compare known weight with the unknown weight. Now, in this case, if the known weight is greater than that of unknown weight, we have to reduce the known weight to 9 kgs. Now, after reducing the known weight to the 9 kgs, again compare known weight with the unknown weight. Now, the known weight is equal to unknown weight, then we can conclude that the unknown weight of a balance is 9 kgs. Like that, each and every time we have to compare our unknown weight with the known weight. With that balanced method, we can find out the unknown weight parameter. Based upon the same principle, the successive approximation type of digital voltmeter works. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.